Okay, radiation. Describe the structure of an alpha particle. Well, an alpha particle is quite simply 2 protons and 2 neutrons. Okay, like that. Which is the nucleus of a helium atom. A helium atom has 2 electrons spinning around this nucleus. So if you take that helium atom, remove those 2 electrons, you're just left with 2 protons and 2 neutrons, and that's an alpha particle. Looking at the mark scheme, you have to say 2 protons and 2 neutrons. If you say 2 protons and neutrons, you don't get the marks. So again, this is a lesson in being detailed in your answers. You've got to be really careful and be precise and detailed. Anyway, which type of radiation is least ionizing? Well, there's alpha, beta and gamma radiation, and it's gamma. It just is the least ionizing. Just remember that. Okay, what happens to the structure of an atom when it's ionized? Right, so if you have some atom and it becomes ionized, that means it's either had 1 or more electrons removed from it, or it's gained 1 or more electrons. An ion is a particle with a charge. So if you take an atom and you remove an electron from it, electrons have a -1 charge, so that's a -1 charge being taken away, which leaves it as +1. So here is some atom, okay? And you take away an electron, that means it gets a +1 charge. If you give it an electron, it's gaining a negative charge, so it becomes -1. Or it could have 2 electrons removed, so it gets a +2 charge. Or it could have 2 electrons removed, so it gets a 2- charge or -2 charge. Okay, so the answer is, what happens to the structure of an atom when it's ionized? It gains or loses. Let's be precise. Either it gains 1 or more electrons, or it loses 1 or more electrons. That's it. Okay. State one precaution when working with radiation. Well, there's a few things. Protective clothing. Work remotely. Right? The source of radiation, get a robot or a robotic arm to handle it or something. What else? Limit your exposure time. So only approach the radiation source for as short a period as is necessary. And you can also work behind a protective screen, like in the dentists. You know when you go to the dentist and they stick your head in that massive machine and it scans your jaw, and you ask the nurse, is this safe? And she says, oh, you know, from behind that massive screen, she runs behind it. Oh yeah, it's perfectly safe, you'll be fine. Yeah, a protective screen, very important. Oh, and finally, get somebody else to do it. Okay, don't put that last one in your answer in the exam. Anyway, moving on. Describe properties of alpha, beta and gamma radiation in terms of penetration through materials, range in air and deflection in a magnetic field. Okay, it's an essay, mini essay question, 6 marks. They've asked you for 3 properties there, penetration, range and deflection, for 3 different types of radiation. So that's 9 things. And it's only a 6-mark question. So just get those 9 things down, regurgitate them and you're done, 6 marks. So let's make a table of those 9 things. In the exam, don't do a table, it asks you to write an essay. So write these things out, but I'm going to do it here as a table. Okay, what's the penetration of alpha particles? Well, they're stopped by about one sheet of paper. Right? Beta particles, they are stopped by about 2 millimeters of aluminium. And gamma particles, they're stopped by about 10 centimeters of lead. Okay, alpha particles range in air about 5 centimeters. Beta particles about 1 meter. Gamma particles range in air about 1 kilometer. Alpha particles, deflection in a magnetic field. They are deflected by a magnetic field because they have a charge. Alpha particles, 2 protons, 2 neutrons. The 2 protons, each proton has a +1 charge, so an alpha particle has a +2 charge, and therefore it will be deflected in a magnetic field. Beta particles, yes, they are deflected in a magnetic field because beta particles are just very high speed electrons, and electrons have a -1 charge, so they will also be deflected in the magnetic field. But because the alpha particles have a positive charge and the beta particles have a negative charge, they're deflected in opposite directions. Okay, so get that in as well. Gamma particles don't have a charge, they're not deflected in a magnetic field. Okay, there you go. You've just got to remember these 9 facts and regurgitate them in the exam for your 6 marks. But don't do it as a table here, you have to write it out in a mini essay in nice, lovely sentences. So there you go, that's it.